In this video, we'll take a look and see how to find an equation from the graph of tangent function. So a reminder of what the tangent function looks like. It has vertical asymptotes at negative pi over 2 and pi over 2. This is just one period of the tangent function. The key points are at negative halfway in between, negative pi over 4, negative 1, 0, 0, and halfway in between, pi over 4, positive 1. So what we're trying to do is figure out how this particular graph and the key points are altered or transformed to give you the new function. So in the new function, if we take a look, if we're given a graph, find the equation of tangent. First thing we do is take a look and try to identify the period. So if you take a look, the period, where are your vertical asymptotes? So on this graph, it's not labeled in terms of radians, it's labeled in terms of whole numbers. So if you look negative 1 to positive 1, that's one full period of the graph. So the period, distance from negative 1 to 1, is 2. So the period of the function is what allows you to find b. The period of the tangent function is equal to pi, because that's the period of the tangent function, divided by b. Substitute 2n for the period equals pi over b, and we end up with b is equal to pi over 2. So that's the value for b when we get to the equation down below. Then for the positive vertical stretch factor, I'm going to start with the vertical shift first. This tangent function originally goes through 0, 0. Now it goes through 0, negative 1. So the vertical shift of this function is negative 1. So that means when we get to the equation, d is equal to negative 1. Now we want to give the positive vertical stretch factor. Take a look at d at your 0, 0 right here, or your middle point, and then figure out halfway in between is 1/2, and where does it cross the y-axis at 1/2? And it looks like it's down here at negative 5. Take a look at the other side, halfway in between 0 and negative 1 is negative 1/2. Follow the graph halfway between until it hits the y-axis, and it looks like it hits up here at 3. And then how far is that from your original point? How far vertically did you count in each direction? So from here we counted down 4, and we also counted up 4. So that has a vertical or stretch factor of 4. So that graph has been stretched 4. Now the tangent function graph is upside down. It's a reflection over the x-axis. So whenever we reflect over the x-axis, our function is negative. So now I think we're ready to put everything in. A is equal to 4, and it's actually going to be a negative 4 in the example, in the equation. So we get y is equal to negative 4 times the tangent. B is pi over 2, so that's pi over 2x. We didn't move horizontally either direction, it just moved down one, so we don't have a value for c. And then d is minus 1.